So far, we have seen single input, single output systems. Today, let us discuss about multi-input, multi-output system, MIMO systems. MIMO system. What is SISO system? Single input, single output system. In a single input, single output system, only one input, one manipulated variable, one process variable. That's all. That is SISO system. In the MIMO system, inputs will be many. Manipulated variable 1, 2, 3, etc. MV, M. Similarly, outputs also many. Y1, Y2, etc. Yn. It has N outputs and M inputs. So that is called the MIMO system. How to handle an MIMO system, that we'll see today. What is control objectives? What are the control objectives? We have to keep the process variables at a set point. We have to keep the process variable at a set point. That is the control objective. So how many process variables are there? In a MIMO system, N process variables are there. N process variables are there. So all the N variables we have to keep at a set point. That is the control objective. Suppose there are L disturbances are there. The N process variable has to reject the N process variable has to reject the L disturbances. So that is the control objective. What are the outputs should be measured? Suppose you want to control N variables has to be controlled, means the number of outputs should be measured is N. Number of outputs should be measured is N. Sometimes it may not be possible to measure the output. For that, in the previous class, we have seen that inferential controls. If you are able to measure directly, then it is called primary measurement. The PVs are able to measure means then it is called primary measurements. Sometimes the variables we are measuring may not be directly involved, maybe for inferential control, or it may be for cascade control. For cascade control also we are measuring another variable, but which is not primarily important. So in that case, what we are doing is there are some secondary measurements are there. Primary measurement means the variables in which we are interested, cross variables. Sometimes in a cascade control or inferential control or split range control, in that some secondary measurements are required. That also we have to measure. What inputs can be measured? We are assuming that all variables are measurable. We are assuming that all variables are measurable. But sometimes it may not be possible. In that case, we'll go for inferential control. Inferential control. For that, we have to measure some variables, or sometimes we may use adaptive control. In that case also, we'll measure some inputs. Here, how many inputs are there in a MIMO system? Multi-input, multi-output system. M inputs are there. M inputs are there and N outputs are there. M inputs and M outputs are there. What are the manipulated variables has to be used? Because M is greater than M. M is greater than N. N is number of process variables. M is number of manipulated variables. Always M is greater than N. Which are the variables has to be used to control these N variables? That is called manipulated variable. What manipulated variable should be used? That is also another question, unanswered. Then what type of configuration we are going to use? What type of configuration that we are going to use as control loop? That is another question. So suppose I want to use M1, M2, M3, and M4 to control PV1, PV2, PV3, and PV4. Are you going to use M1 to control PV1 or M1 to control PV2 or M1 to control PV2? That is called configuring the input outputs. How to configure? That we have to decide. So these are the problems will be there in the case of MIMO process. We'll answer one by one. Before going for that, what is degrees of freedom? Degrees of freedom already we studied. Degrees of freedom F equal to number of variables minus number of equations. Total number of variables involved in that system minus number of equations. We can define the degrees of freedom as the degrees of freedom of a given process as independent variables. Independent variables that must be specified to define the process completely. Suppose we have 10 variables and we have 8 equations, means 2 is the degrees of freedom. It means 2 independent variables are there that is not yet defined. Therefore, the system is not completely defined because there is no equation to specify those 2 variables. That's why the degrees of freedom equal to 2. It is not completely specified. In other words, the system is not completely specified. If F equal to 0, then we can say that the system is completely specified. To specify completely, there are 2 sources to specify them. One is called external world. External world can be used to specify unspecified variables. To make degrees of freedom equal to 0, we can use 2 sources. One is external world. For example, the feed flow rate is there. Feed temperature, TI, is there. Inlet temperature of TI is not in our hand. That is depends upon the environment. That is specified by the environment. That's why TI is specified. TI equal to function of ambient temperature. Ambient temperature. That is one equation. Ambient temperature. So suppose the degrees of freedom equal to 2 means 1 we defined like this, means that degrees of freedom reduced to 1. We can write equation. Means we are specifying. For that we can use the external world. Suppose I am having one unit, the unit operation 2 is there. For that unit 1 gives input. Unit 1 gives input. The feed is coming from unit 1. That we cannot specify. The feed flow rate coming from the unit 1 we cannot specify. That's why it is function of unit 1. Function of unit 1. So like that we can define. So we can reduce the degrees of freedom. Or suppose I want to define the pressure here. It supplies to the next unit. It depends upon the pressure of that next unit. That is unit 3. Its pressure will vary. That's why the downstream pressure is function of unit 3. Like that we can define one pressure. The downstream pressure downstream pressure P2 is function of unit 3. Like that we can define. That is called external specification. Another way of specifying is by using control system, we can specify the variables. For example, I want to define the level. Level is function of inflow rate Fi. This Fi is defined by what? Fi equal to function of control variable, manipulated variable, that is controller output. So I can write H is directly, I can write H equal to function of manipulated variable. This is one equation. This is based on control system. So we can make degrees of freedom equal to 0. That is, we can specify the system completely by using the two sources. One is by using the external world or using the control system. Now, how many independent manipulated variable we need to, in order to keep the controlled outputs at their desired value? Suppose we are having n controlled outputs. Controlled outputs, process variables, how many? N. So how many manipulated variables are required? The manipulated variables also equal to n. Manipulated variable also equal to n. So n controlled outputs, number of manipulated variable is m, that is greater than n. The number of disturbances L. Therefore, number of manipulated variable must be equal to number of process variables. We have to pick n manipulated variable among m. Out of m, we have to select n manipulated variables. We have to select n manipulated variables. So number of, so how the variables, suppose n variables means how it can be defined. Y1, first process variable. Y1 is function of manipulated variable M1, M2, M3, M4, etc. M, and D1, D2, D3, etc. DL. L disturbances are there. M manipulated variables are there. Any one of these varies, Y1 will vary. That's why Y1 can be defined as function of M manipulated variables and L disturbances. Like that, Y2 can be defined as function of, again, M manipulated variable and L disturbances. Out of this, how to select the N manipulated variable is the question that we have to find. So number of controlled variable equal to number of manipulated variable. Number of controlled variable equal to number of manipulated variable. We know that number of controlled variable equal to degrees of freedom minus number of externally specified equations. Degrees of freedom 2 means, so we can write two more equations only means. One is specified by externally specified. Another one is by control system, means the degrees of freedom becomes 0. Degrees of becomes 0. Therefore, number of controlled variable equal to number of manipulated variable equal to F, degrees of freedom, minus number of externally specified. We cannot specify some variables in that case that is specified by external, that we have to subtract. That is the number of controlled variables. So number of process variables, that is controlled variables, equal to degrees of freedom minus externally specified variables. Externally specified variables. Externally specified variables. The degrees of freedom at dynamic state is always greater than at steady state. If you consider a level process, what is level process? This question, after seeing that level process, we'll see that degrees of freedom at dynamic state is greater than at steady state. That we'll see after seeing the degrees of freedom of level process.